All right, welcome back again. We're back again. More C++. This time we're going to go into the OOP more in depth. I'm Adam Rushford. If you're new here, it's nice to meet you. I highly suggest if you're interested in learning C++ that you go ahead and subscribe to my channel and hit the notification so that you can follow along as I do live updates. And if you want to interact, that's fine. I'll try to interact with you guys along the way, but I would appreciate if you kept the comments to a minimum, but you know, people are going to do as they do. I turned down the music this time. It's still up there, but I'll try to speak a little louder. It's a little quiet to begin with. Anyway, let's get back to it here. So, first we're going to learn about encapsulation. So here's we got a player class, okay? And that's all we have. So nice and simple. We're not interacting with classes yet. We got player, and then so encapsulation is when you allow the bundle of data and methods, functions, members and functions that operate on the data and control the access to the data. Essentially, you're using public, private, protected. Now, here's what I'm going to tell you. Don't use protected. Protected falls along that same line of you really got to know how it works, just like the friend, the friend class thing. So, what this is doing is it's declaring or it's implementing the class. It's saying player, this class, and then it's just calling it P. And player, they're giving it two numbers. See down here, this is what's called a constructor. And the constructor can actually be, a constructor is basically the same name as the class, but it's a function. So it can look like this. You have class, player, and you have your scope of your class. Oh, not sure what that was. You have the scope of your class. Here, I'll just copy and paste this. This will be easier. Okay, so let's just remove some of this stuff for a second, so it's a little easier to see what's going on. Okay, maybe not. All right, so you can have classes have what's called a that's what I did wrong. Classes have what's called constructors and deconstructors. That's not really news. They also require a semicolon after you declare them. So the constructor is essentially just a function of the class. And that is automatically called when you instantiate a class, which is to say this part right there is an instantiation. Okay? It's a declaration, sort of. It's like a forward declaration, but it's also an instantiation. That is where you instantiate it. That is where you created it. And that is literally in the code where it gets created. This is a declaration, which doesn't get created until you instantiate it somewhere. Okay? That's the difference. Okay, so, excuse me. You can barely see that. Okay. Okay, so, what's this all about? All right. There's also something called a destructor. When you start to use OOP and mix these together, you're going to need this as well, a lot of the time. It's for the deconstruction. Like if you were to call something new here, you would have to call delete here, or you would have a memory leak. Okay? So that's what a constructor and deconstructor is. Now, you don't actually have to have these because it automatically creates a default one. If you were able to see basically the ghosted code behind this code, you would see it already has this. And you can create your own, and then it would have both sets. You can see that sometimes in the debug information. Anyway, the point I'm making is that you don't have to create them. They're automatically created. But you can create them on your own as well, and then take control. They override. And a lot of times when you create a class, right on instantiation, it needs to do something. Like, let's say, here's a good idea. Let's say player is not a character, but it's a music player. So you would want, like, the name of the file. You would want the name of the file it has no member file name. Oh, well, that's what I meant. There we go. Okay, so let's say you wanted player, your music player, to have, and this has to be named the same, by the way. All those have to be named the same. But you can actually have different constructors, and you can use a default constructor so that when you go to instantiate it, it actually looks like you can actually instantiate it like that with a default constructor. Or you could have a totally different one that loaded up a file name by default. Now, why is it that what's going on here? It did include string. What do you mean? It's right there. Anyway, it's included. Anyway, that's so that you could actually have two. You could say MP1, MP2, MP3, whatever. Not to confuse you with that. So you could actually have different implementations of the of the class. Sorry, I was just looking at file name and wondering why. First of all, why is it doing that? And second of all, but that's what you would do with a class. You have the constructor and the destructor, but you also you can have multiple implementations. In C++, you're casting these functions, these classes, these things out into a void, essentially. But that void has pockets. That's what scope is. And in these pockets, they have creatures that live in them, and the creatures are the classes, and they there's different types. Just like there are different humans on Earth, there are different constructors. We're all made from different molds. So that's what these are. They're different molds, and they give you different implementations so that you can do things like this. So that's that. Now we understand what this is. Okay, so what this is doing is it takes arguments. Oh, sorry about the phone. I might have to end the stream if she keeps talking. So, integer hit points, it takes arguments like we have 100 hit points, and we have, what's this? Shield? Oh, score. We'll just say if score starts at 0, and you see that works. So, what is this part? This is what's called, oh geez, I forget what they're called. They're the member initializers, I believe they're called. And where does this come? Like, what is this? Okay, so you've got integers to handle these, and then it's taking these arguments, put them in here, so that this is getting placed into the private member. So this is a way to initialize a private member from a public constructor. That's basically how classes work. This is the word's escaping me at the moment. Just a second, I'm trying to pull this up. This is the encapsulation in the private area of the class. The constructor, this constructor is in the area of the class, and it's got some implementation because it's in one CPP file or one H file. This is a legitimate program. This will run. It doesn't do a whole lot, but it works. And it shows you how to basically properly construct a class. Then there's inheritance, and inheritance is where you use the class initializer to declare the class as an inherited member of another class. So character is the base class, player and enemy inherit from character, and they get the move command from it, so they can override it as a virtual member. They can override it, and then it will actually call different implementations based on that class, depending on whether it's a player or an enemy. But it also has, and I don't know what this final is, we'll have to learn about that. But then, if neither of these get declared properly, or if you just wanted a generic character, then it would do this as well. It may actually, no, actually it would override this. It wouldn't actually fire. If this fires, this will not. But if this is not here to fire, this is a backup for it. As long as it calls into the character class. As a inherited class, it should fall back to this. Yeah, it doesn't show any demonstration of this happening. It's like the control case where you don't see it because it overrides it. It overwrites it so that it never happens. And that is inheritance. Then you have polymorphism. Polymorphism is where it has make a sound, and it's a pure virtual function. It has no implementation, and you override it, and this is more of a generic class that can actually be implemented as an interface and not even be inside your main implementation. And this would just be your main implementation. And then you can create a vector of animals. See how it uses animal? That's why you need your base class still. So you'd create a vector of this generic type of class, and then you would create new implementations of specific inherited classes within it. and they are equal to each other in that regard. What's not equal is their implementation. So when you actually fire them, you get this command rather than this command. And if you're going to use new, you have to make sure to use delete. And this is basically making a list of animals, and then it creates new implementations. So you're only getting one, so you don't have to make lists of each one or unique pointers or anything like that. And then because it's handled in bulk, it can be cleaned up in bulk, and the delete is just called on all animals. If they exist, they get called delete, and it takes care of these. And then there is abstraction, and we already learned abstraction. That's templated classes with concepts. This is concept-based abstraction. And then there's some more complicated stuff, which is aggregation and composition. Aggregation represents a has-a relationship. Yeah, great time for that. Where an object is made up of components. The composition implies ownership and life cycle management, and you use unique pointer and safe memory management. So in this case, the car creates a unique pointer of an engine, and then it implements engine within its class, so that you actually call car as more of the base class, and then it has an engine that drives it. And you could have different implementations of engines, or different implementations of cars, and they could both kind of
Hello, Moto.